Hello, welcome back. Um, in the previous video, what we did was we wrote our first in-class exercise where we read in the radius of a circle for the first time using input function. And then we computed the area of a circle, and then we calculated the calculated area on the console. And then we left off the video with another exercise that's supposed to be a self-study for 10 minutes. Um, I don't know how long it took you. It doesn't have to be exactly 10 minutes. So it's another similar program that asks the reader, the user, a Celsius degree and then convert the Celsius to a Fahrenheit, and then it displays the result. And here is the formula. Okay, let's do it together. So I'm going to, so you can continue the same program using different boxes, right? So this one is in class exercise 2. So we have, so we can do it in 3 steps, right? Step 1, step 2. So let's design the algorithm. The algorithm is actually given here. So it consists of 3 phases, step 1, 2, and 3. And the first step asks us to read in a Celsius degree from the user. So read in the Celsius degree from the user. Okay, so we have a new variable called Celsius, and we are going to read in. Please input a Celsius degree and press enter. So similar to the previous example, we use the input function. We read in the Celsius, but Celsius now is a string variable. We need to convert it to a number, numeric variable, using the float function, okay? Just like before, nothing is different, except that it's not radius now, it's Celsius. And then in the second step, convert Celsius to Fahrenheit. Okay, let's compute the Fahrenheit degree from Celsius degree. So we are given this formula down below. So we have Fahrenheit, I'll just copy it, Fahrenheit, that is equal to 9 divided by 5 multiplied by Celsius plus 32. Yeah. And so this is the second step. We computed the Fahrenheit degree and display the result here. Can write a sentence. Celsius degree of, here is our degree value, let's say it's 35. Let's say Celsius degree of 35 is equal to, we have Fahrenheit as the value, like the number, of Fahrenheit degree. Awesome. So let's run this. Please input the Celsius degree and press enter. Let's say 35. And then it goes, the Celsius degree of 35 is equal to 95 Fahrenheit degree. Okay, so that's the second exercise. So let's look at the answer on sheet, on paper. So we again read in Celsius degree from the user, convert it to number. So here it's text, here it's string, because the input function always returns string, not number, not number. Okay, so we have to do the conversion. So this is string converted to a number. Okay, and then now we convert this number, the Celsius number, to a Fahrenheit, and then the Celsius degree of Celsius equals to Fahrenheit degree. Okay, so let's do a review. The question: input statement reads in a value from the user as numeric, true or false. Here again, I'm going to tell you the answer, but before I tell you the answer, you can stop the video and then try to guess it on your own, and then continue to see the actual answer. So the answer is false. We just learned that input statement reads in a value from the user as string, right? As text, not number, not numeric. So what does the following program print? We have a radius 7.5, and then we print radius. So does it print 7.5 or just the radius? The answer is that it prints radius. So why prints radius? Because of the double quotation marks, right? So remember last week we printed hello world. So instead of hello world, we have radius here. So if you enclose a text with double quotation marks, it prints whatever inside as text as is. So it doesn't print the value. So we have a radius here. And then, so it is the name of the variable and the value 7.5, but we are not printing this one. It's not this. Why? Because without the double quotation mark, that would be the 7.5, but we have the quotation marks. So it doesn't, so radius here does not indicate this variable. It is just a text, right? That's why the answer is B. Another similar question: what does the following program print? So now we have radius equals 7.5, and then we printed radius. So now the answer is A, right? Because now what we print is, so we don't have the double quotations. So here radius is just the name of the variable that stores the value 7.5. So that's why we print 7.5, not radius as a text. Okay, so another in-class exercise that you can again practice at home. Similar one. Here I'm asking you to write a program that reads 3 numbers from the user and displays their average. Pretty simple. Instead of just one number reading that we used in the previous examples, here you have to do it 3 times and then display their average. Okay, so you can take as long as you want. This is a practice at home exercise for you. You can actually stop the video right now and then do it. I'm not going to talk about it in this lecture, but I'm going to post the answers online. So please follow my website and the Canvas, the Tilburg University website, for details. Okay, so we have done a lot of exercise and practical programming skills we gained. Now let's look back and then try to understand what we learned so far. Okay, so we actually know what they are, we just didn't formally explain them. So here is the first one, identifiers. What is an identifier? So identifier are the names that identify the elements such as variables, constants, methods, classes, packages in a program. So for instance, radius was an identifier. So it's a name of a variable, for instance, right? So radius here is a variable. Can be a name of a method like input or print. They're also identifiers, but these methods are built in. They're built-in methods. If you want to write up your own method, which we're going to learn in the last lecture, you're not allowed to use the built-in methods names, right? And then you can also name classes, packages, or constants. We're not going to talk too much about it. We're only going to learn the variables and the methods. But for this class, so for this lecture, we are only going to talk about the variable names. So an identifier is a sequence of characters that consists of letters, digits, and underscores, nothing else. And it must start with a letter or an underscore, so it cannot start with a digit. So you can have an identifier, for instance, instead of radius, we have radius underscore of a circle, for instance, right? So you could have done that instead of the radius, but we just use radius. So you have the freedom, but know that your freedom is sort of limited in either letters, digits, or underscores. So you can have, for instance, radius 15 or radius 1. For instance, let's say we are going to use several radiuses, so you can say radius 1, radius 2. You can even use like radius underscore 1, radius underscore 2, something like that. So these are all possible. An identifier cannot be a reserved keyword. For instance, import, return, except, if, else, input, print, and so on. So they are reserved keywords, so you cannot name your identifier. So they cannot be true or false. So these are the no-go rules. Can be of any length. So it can be like 1, 2, 3, 4. No, it doesn't have to. Sorry. So it can be like a radius of a circle with some nice drawings, and so it can take a lot, but it can be as long as you want. Okay. And Python is case sensitive, so area with capital A, area all lowercase letters, and area all capital, they are all different identifiers. So if you have, for instance, area is 5 and then area is 6, so they are different, right? So there is an area here inside the computer's memory, and there's another variable called area, and that's 6, so it doesn't overwrite on this one, so it doesn't do it because they're not the same. So this one starts with a lowercase a, this one starts with an uppercase a. So variables, the program needs to read the radius entered by the user from the keyboard. So this raises two important issues, right? So you need to first read the radius, but you also need to store them, okay? So remember in the very beginning, I only did an input and then please enter, and then when the user enters 10, for instance, the 10 goes away, so it vanishes. So without setting up 10 to a variable called radius, so this 10 is not usable, not reusable, let's say, unless you defined a variable and then assign that to there, okay? So that's why in order to store the radius, the program needs to declare a symbol called a variable. So that's the variable that we're talking about, the radius, okay? So we know this, but we didn't properly explain them. That's why we're talking about it. So it's not like something new. It is just a refurbishment of what we already know. So the variables are used to store values to be used later in the program. So that's why they are reusable. So you can use the variables multiple times, okay? So they are called variables because their values can be changed. So they're not fixed. So you can have, for instance, radius equals 5, and then radius equals 6. So what happens then, so this is the radius box inside the computer's memory. Used to be 5, and then 5 becomes 6. So we don't go like create a new variable another place and then set it up to 6. So we don't do it. What we do is we just rewrite what we have. So it used to be 5, and then we rewrite it, make it 6. So their values can be changed. So we need to tell the compiler the name of the variable. Usually the name should be descriptive as possible. So if you're storing a radius, just call it radius. Don't call it like r. Although it's a short version of the radius, it is not descriptive. So someone else reading your code might look at it and say, okay, what is r? I know what r is, but is it really what I think it is? Or it's something else? So please be as descriptive as possible. Just name them like radius. If they are radius, just name it radius. Or if they are area, just name them area, okay? And the assignment statements, this is also something that we learned. We can assign a value to a variable by using an assignment statement, that is the equal sign. So this equal sign is going to help us assign the right-hand side to the left-hand side. So remember, we talked about the right side of the equal sign as the right-hand side. So it assigns the value on the right to the variable on the left. So this syntax is the following. And here the expression can be, so it can be like radius equals 5, only like a number, like just like a value. Or after setting this up, we can also set it to radius plus 5, something like this. It can be an operations that takes the value of the variable that evaluates to something, or it can be like area equals radius multiplied by radius and multiplied by pi. Okay. So first, the right-hand side expression is calculated, and then it is assigned as the variable value. For instance, here we have 1 as a value, only a value expression. X is just a variable name. Now we assign 1 to x. Here again, 7.5 is assigned to radius. So we don't have to assign values only, like numbers. We can also assign such as a string or a text, like capital A. That stands for the lowercase letter variable a. So here is so it's a bad variable naming. It's called a, and inside the box here, so this is the variable name a, but this is the value. Okay, so we have capital A as a value, but the variable name is lowercase letter a. And here we have a double statement. So the first one is 2 assigned to the count variable. After assigning 2, what you have is count equals count plus 1. So remember, always do the right-hand side expression computation calculation first. So the count is now 2. 2 plus 1, it's 3. And the new value of count becomes 3. So count used to be 2 here after the first statement. So we have a count variable. Inside the box, the value box says 2. And then after the second one, here we have to do the calculation. So 2 plus 1, 3. Now we are rewriting. So we are changing the values, the variable's value. It used to be 2. Now it is 3. Okay. So you can do this. Always look at the right-hand side and name the variable on the left-hand side. So here we have a radius on the left side. But if we do it on the right side, if we say 5 equals radius, this will be incorrect because the value should be on the right and the variable should be on the left. So this is the correct way, okay? So be careful. All right, let's do a quick recap or review. All right, so the question goes, which of the following are valid identifiers? Okay, let's check them one by one. So lowercase letter a, is that a valid identifier? I mean, why not? It doesn't violate to any rules that we know. So let's look at B, plus app. So here it's not a valid identifier. Why? Because we cannot use plus. In identifiers, right? So we can only use a letter that is A, B, C, D, or numbers that is 1, 2, 3, 4, or underscore. That is the underscore here. So we cannot use, so there is no plus in this list, right? So we can either use letter, number, or underscore. We cannot use plus. And it has to start with a letter or an underscore. So it cannot start with numbers. Okay, so for instance, C, we have 3 numbers. This is incorrect. radius of the circle, this is, I mean, pretty good. So you can have lowercase or uppercase, no issue, but just know that it is case sensitive. So $2, no, we don't have $sign. B plus 7, no, because again plus. Okay, true. So this was a reserved word. So we cannot use true or false. So it's either A and D, okay? All right, so numeric literals. So a literal is a constant value that appears directly in a program. For example, 34 or 0.305, they are literals. They are numbers in the following statement. So here we have 34, 0.35, so they are numeric literals or numbers, you can say it, right? And there is a distinction between an integer and a floating point number. So an integer variable, so they are 1, 2, 3, 4, and so on, okay? So it cannot be, for instance, 1.5, so this is not an integer. Or like 2.75, that's again not an integer. 3.14159 pi is not an integer. It has to be a whole number, right? For instance, here 3 is an integer. And if you actually print type integer variable, what you'll see is that it is a class of int. Means that it is an integer variable. And the floating point literal number, so it can be written with a decimal point, okay? So for instance, 3.14, 2.5, 1.0, so this is also float, okay? It's called a floating point literal, or short version is float. So if we actually use this one after inputting the radius, for instance, we use float, right? Because we didn't want to, remove the decimal point. So what if the user, so we have the radius equals input, please, right? So what if the user decides to input 7.5? If we convert to an integer, the 0.5 is gone, it'll only be 7, which we are losing precision, right? So that's why we converted this input to a float. So 7.5 used to be a text. Then we said float radius, that's equal to radius. And then we converted the text 7.5 to a number 7.5. Okay, so you can convert the floating point literal to an integer or vice versa. So if you convert the 7.5 to an integer, for instance, it removes the decimal point. We have number before conversion 3.14. And then if you do the conversion, just like float, we can use do a conversion by writing int used to be 3.14. After the integer conversion, 0.14 is gone, so it becomes 3. The type becomes class, the int, and then if you actually print the number, it displays 3 without the without 145. So if you do the conversion from float to an integer, you're losing precision. Or you can similarly convert an integer to a float. What it does is it simply adds a decimal point and a 0. So this was the integer value 3. After the conversion, it'll be 3.0. So you don't lose nothing. The class becomes float after the float number after conversion becomes 3.0. Okay, and we have numeric operations. So for instance, we have plus, minus, multiplication and division. So they are pretty straightforward. I'm not going to talk about it. So it's just like 34 plus 1 is 35, right? But the remainder operation, so this may be something new for you. So what it does is, so 20 remainder 3, 20%. So this is a percent sign 3. What it does is, so you have 20 to 3, right? Okay. The remainder is 2. Here sets up the remainder. Remember high school math? It is the remainder, okay? And we have 3 different division functions. One is simple division operator. So it always results in a floating point number. For instance, 5 division 2 is going to be 2.5. Although this one is integer, and this is also integer, the result is float. But I'm talking about the division operator. We also have an integer division operator that's going to be something else. So we won't have float there, okay? And there it comes. Integer division. So 5, 2. But if you have integer division, the result is not going to be 2.5 anymore. It's going to be 2, okay? And the remainder is just the remainder, 5. So let's do it. 5 by 2. We have 4. Remainder is 1. There you go. Okay. So remainder operation, we are going to use remainder operation a lot. So they're very useful in programming because, for instance, to detect the even number or odd number, if you do remainder by 2, it's going to be either 0 or 1. And 0 and 1, it's really important in programming because so it can be true or false, or just like a binary digit, right? 0 and 1. So computers love 0, 1 type of a thing. So that's why we are going to use remainder operation. It's going to be so useful in programming. So the result of a division operation is always a floating point number. So if you have, even though you have the two numbers as integer, the result will always be 2.0. But the result of an integer division and remainder, now it depends on the types. Okay, so it's not always like in division. It depends. So if at least one of the two numbers used in the integer division and remainder operation is floating point number, then the result will be floating point number. So like 5.0 remainder 2 will be 1.0 because this one is float. Although this is integer, the result is float. But if we have both variables, integer, so like 5 by 5 remainder 2, now the result will be just 1, okay? So, okay, so we have a couple of examples. So we have 7, integer division 3. So the result, integer division result will be 2.0 because we have 3.0 here. And since this is integer division, it's going to be either 2 or 2.0. So it's not going to, so it's not 2.3 3, 3, 3, 3, 3, 3, 3. Because that's what 7 by 3. If we do for instance 7 division 3, this is the result, right? 2.333, it goes on. But since this is the integer division, so we have double slash here. Now the result will be only the integer part. It's not 2.333, it's only 2. But again, since here we have 3.0, now we'll add up 2.0. Also, 1 is float, so the result is 1.0, just like I explained in the previous example. But if the two numbers are both of them integers, the result now will be integers. So 7 and 3, so they're both integers, the result is 2, not 2.0. Again, both integers, the result is 1, not 1.0. Okay, so I'm going to stop the video because we have a self-study in class exercise. So in this exercise, I want you to write a program to obtain minutes and remaining seconds from an amount of time in seconds. So what the program does is it first reads in the time in seconds from the user using the input function as always. So we have, for instance, the user said 200 seconds. And then your program converts 200 seconds into minutes and the remaining seconds. So 200 seconds is 3 minutes and 20 seconds. Okay, so I'm going to stop the video now. I'll give you 10 minutes or how long you would like to take. So you can take 15, 20, doesn't really matter. And come back in the next video lecture and we are going to look at the result together. Okay, I'll see you in the next video.